Hello everyone, very good evening and welcome to Prep Funda. This is Sanjay Rathi. How are you guys? So very good morning and happy Diwali. So today we are going to solve some important numericals on operational amplifier. इस दिवाली की शुरुआत शानदार है दोस्तों, बहुत सारी अपॉर्चुनिटी है आप लोगों के लिए और आपको टाइम का भरपूर यूज करना है, राइट, सो दैट यू विल गेट द कमांड ओवर व्हाट ऑल द टॉपिक्स। और इस साल आप जितने भी कॉम्पिटिटिव एग्जाम्स दे रहे हैं सब में आपकी जो रिजल्ट्स आने वाले हैं दैट व्हाट जो आप जैसा चाहते हैं उस लेवल पे आपका रिजल्ट्स जाएगा दोस्तों। ओके, so start your preparation with me and I am going to solve some important numericals on operational amplifier. This is a question practice series live session, right? This is the analog electronics. Okay, let me know that sound quality, picture quality, everything is fine. Everyone, 1 minute. Okay, now everything is fine. Everyone, very good morning. Then so guys, so Shiva, very good morning. Now this is a operational amplifier from analog. We will solve some important numericals on various topics. I will mention the topics, what are the important topics we are going to discuss, and that is for GATE and Engineering Services exam 2025, 2026, okay, and other competitive exams. Now, first of all, that is my introduction. Myself Sanjay Rathi, 24 years of teaching experience, and these are my ranks in engineering services exam AIR 16 and AIR 21. And let's remember this time IRMS, Indian Railway Management Service through engineering services exam. Okay, first thing. Second, इस बार आपको गेट के बाद sufficient time मिलेगा for engineering services pre and then you will get sufficient time for what mains. And that's why first of all fill the form for engineering services exam. If you are eligible, for example the final year students are eligible, droppers are eligible, general category up to 30 years you are eligible. No doubt you are in college or you are in job या आपकी शादी हो गई है, राइट, अभी आपका पढ़ाई ब्रेक हो गया है. अगर आप एलिजिबल हैं तो फॉर्म जरूर भरिए क्योंकि कट ऑफ मार्क्स काफी कम जा रहे हैं एंड दैट इज द गोल्डन अपॉर्चुनिटी फॉर यू गाइस. कंपटीशन बहुत कम है, 5 साल बाद अपॉर्चुनिटी आई है तो लोगों ने तैयारी छोड़ दी थी, वापस सब तैयारी स्टार्ट करेंगे तो सब बराबर लेवल पे है. कोई भी इस एग्जाम को क्रैक कर सकता है. स्पेशली आई एम टॉकिंग अबाउट गर्ल्स कैंडिडेट. जो फीमेल कैंडिडेट्स है उनको अपना फॉर्म भरना चाहिए और सिंसियरली तैयारी करनी चाहिए. कहीं भी मूव मत कीजिए, ऑनलाइन क्लासेस आप स्टार्ट कीजिए और अपने घर पर प्रिपरेशन स्टार्ट कर दीजिए. देन दैट इज माय एक्सपीरियंस, सीधा बनोगे आप क्लास 1 ऑफिसर. एंड दिस इज माय चैनल इलेक्ट्रॉनिक्स बाय संजय राठी. यहां आप अपने कमेंट्स दे सकते हैं. आप ऐप इंस्टॉल कर लीजिए जिसका आपको लिंक डिस्क्रिप्शन पर मिल जाएगा, जहां बहुत सारे फ्री कंटेंट्स अवेलेबल हैं, राइट, नोट्स अवेलेबल है, पीडीएफ है, क्वेश्चन पेपर्स अवेलेबल है. गो थ्रू इट, यू विल गेट द आइडिया हाउ टू क्रैक ऑल दीज कॉम्पिटिटिव एग्जाम्स गाइस. नाउ अब आते हैं जरा, आज का टॉपिक है एनालॉग इलेक्ट्रॉनिक्स ऑपरेशनल एम्पलीफायर. दिस इज अ क्वेश्चन प्रैक्टिस 1. वी हैव टू अरेंज अराउंड 3 to 4 क्वेश्चन प्रैक्टिस ऑन ऑपरेशनल एम्पलीफायर. तो व्हाट आर द टॉपिक्स हियर? फर्स्ट ऑफ ऑल इन दिस सेशन we are going to discuss some important topics guys. So I'm just first of all I will give you the idea about the what are the important topics in this session, right? Give me 1 minute. To new students, all the new students, please first of all subscribe the channel. Then okay, now in this session we will discuss question on inverting op amp, inverting operational amplifier, then non-inverting operational amplifier, very important question, right? Like find the gain for ideal operational amplifier, practical operational amplifier, find the input resistance and so on. Then on all the topics are what are the feedback mechanism, then differential amplifier, this is the important topic. Then guys, voltage to current converter, right? And then current to voltage converter and differential amplifier, and there is one amplifier that is called what? Instrumentation amplifier. We will solve question on these topic. All questions are very important. So I'm going to start my session, guys. First question, quickly we are going to solve, guys. First of all, remember, these are the properties of the operational amplifier. So we will solve questions on the properties also, like what? AV infinite, RI infinite, output resistance 0, gain bandwidth product infinite, bandwidth is infinite when the gain is 1, CMRR, common mode rejection ratio, question on common mode rejection ratio, then question on what? Slew rate. Question on slew rate. Then 1 minute to watch these properties. Give me 1 minute. Okay. Now I'm going to start with what? First question. What is the first question here? These are the properties, guys. We will solve questions on slew rate as well as CMRR. Then now quickly, the inverting op amp shown in the figure has an open loop gain of 100. So what is the answer? For example, just for quick revision, when we are talking about the inverting operational amplifier, what are the important topics here? That what is the gain is given 100. If the gain is 100 given, means it is a practical operational amplifier. If the RI is not given, means RI is infinite. R0 is not given, means R0 is what? 0. These are the parameters. Open loop gain is 100, means operational amplifier is non-ideal. Then Ri not given, infinite, R0 0, and that is the case. So normally what is the gain under ideal condition? Minus Rf by R1. Minus Rf by R1 means minus 10, but it is a under ideal condition. It is called, or always remember, it is called open closed loop gain. This is the V out by V in after feedback. This is called closed loop gain. Under ideal condition, when we are putting the virtual short concept, that is the basic answer, minus Rf by R1, 180 degree phase shift. But since it is a practical question, so what is the answer? जो क्लास में अटेंड कर चुके बता दे जरा. Yes, please. So Bitan, how are you? Very good morning. Now, so guys, first of all, every new students like the session, share the link of this session and subscribe this channel so that you will get the notification about all my coming sessions. नवंबर और दिसंबर ये रिवीजन का मंथ है, तो नवंबर, दिसंबर और जनवरी 3 महीने भी अगर आपने सिंसियरली पढ़ाई की तो आप गेट और इंजीनियरिंग सर्विसेज एग्जाम दोनों में टॉप रैंक अचीव कर सकते हो. तो बिना डिले किए अपनी प्रिपरेशन स्टार्ट कर दीजिए. देखिए, अब आते हैं इन केस ऑफ नॉन इन्वर्टिंग ऑपरेशनल एम्पलीफायर द फीडबैक मैकेनिज्म इज वोल्टेज शंट फीडबैक. दैट इज अ थ्योरेटिकल क्वेश्चन और वी विल डिस्कस इन व्हाट? फीडबैक टोपोलॉजी. तो दिस आंसर इज रॉन्ग. मींस व्हाट इज दिस? दिस क्वेश्चन इज व्हाट? MSQ, मल्टीपल सेलेक्ट क्वेश्चन. तो in multiple select question, remember in inverting operational amplifier feedback mechanism is voltage shunt feedback. Okay, voltage shunt feedback. Very good morning, Kamini and Siva. Now, second thing, if it is a if it is a practical condition, this is a quick revision, guys. If it is a practical condition, always remember the gain is given by closed loop gain. This is called the closed loop gain is given by minus AV beta upon 1 plus AV beta into RF by R1. This is the formula, minus AV beta upon 1 plus AV beta into RF by R1. So what is the beta here? Beta is R1 upon R1 plus RF. Remember, this is called feedback register because it is between input and output, and this is the input or coupling register R1. So RF by R1, you can find the beta. This is 1 by 11. Now you can put the value and you will get the gain. Minus 100 it is given, 1 by 11 it is given, 1 plus 100 into 1 by 11 it is given, into what RF? RF is 10 divided by 1. Right? And now you will find nearly equal to what? Minus 9. So gain is what? Minus 9. So for this particular question, this is correct answer. So what is the exact gain? Minus 9. What is the approximated gain? Minus 10. Means it is, approximation is what? Overestimated. Approximated value is overestimated. Now, what is the error in approximated calculation then? You can find the error. Direct formula error 1 by AV beta into 100%. This is the formula for the error. So it will become 100 into 1 by 11 into 100. So it is 11% is the calculation. Otherwise, you can find approximated minus exact upon exact. So what is the formula for the error? What is the approximated value? 10. What is the approximated value? Approximated value 10. What is the exact value? 9. Just magnitude. Magnitude is 10, magnitude is 9 upon 9 into 100%. And you will get 11%, nearly equal to 11%. So it is a overestimated value. So magnitude is 10, exact value magnitude is 9. 10 minus 9 upon 9, it will give you the error. ये है error. Now, so everyone, happy Diwali. How are you? What about your preparation? Then guys, what is the third question? It is MSQ actually. Input resistance seen by the VS is 1.1 kilo ohm. Now what is the input resistance seen by this? So input resistance under ideal condition is, under ideal condition, the input resistance, this is 0, this is 0. That's why the input resistance is what? 1 kilo ohm. Under ideal condition. 1 kilo ohm. Under ideal condition. But when the voltage gain is given, 100, then you have to apply the Miller's theorem. You have to apply the Miller's theorem, guys. So what is the Miller's theorem here? According to Miller's theorem, break this resistor. Break this RF. This will become 10 upon 1 minus AV. And this is R1, 1 kilo ohm. And now you can find what is the input resistance seen by the VS. And here again, according to Miller's theorem, you can break this resistor AV into 10 upon AV minus 1. Now remember, always remember, if you are going to take the VN, VP, this is the VN, negative terminal voltage, positive terminal voltage, let this is the VI. If you are going to take the VI, VP minus VN, then AV is 100, positive value. If you are going to take the VI, VN minus VP, then AV is equal to what? Minus 100. Always remember, if in any particular numerical mod of AV is given as 100, so it depends whether it is positive or negative value. Positive value means what? When the VP minus VN. And you have to take the negative value when it is a VN minus VP. This is a very important concept here on operational amplifier. Yes. So this is for just quick revision, right? This is the minus 100. Then simply put the value And what is the input resistance of the operational amplifier? Infinite. Infinite, parallel with this, it will remain this. This plus this is the input resistance seen by the Rin. So what is the Rin? Input resistance seen by the Vs. 1 kilo ohm plus 10, 1 minus AV. What is the AV? Minus 100. Minus minus plus, and it is nearly equal to 1.1 kilo ohm. So exact value is higher. Exact value is higher, 1.1. And what is the approximated value? Only 1 kilo ohm. Approximated value is 1 kilo ohm, guys. Means approximated value is underestimated. Underestimated. Right? And you can find the percentage. How much percentage it is underestimated? What is the exact value? 1.1. What is the approximated value? 1 upon exact value into 100%. So you can say by this amount it is underestimated. Underestimated. Because its value is less. Underestimated. This word is very important. Underestimated. So practically we are getting the more value of the input resistance according to the Miller's theorem. Which theorem? Miller's theorem. Okay. So this is the question. Now next one. Next question, guys. Okay. So similarly, this is the inverting operational amplifier. So now watch this. This is the MSQ. So feedback mechanism is a voltage shunt feedback. That's why it is wrong. This is correct. Input resistance. This is correct. Error in the approximated calculation will be 11%, and that's why the answer for this question is BCD. BCD. Okay. Now you want to solve some more questions on this. तो आइए फिर मैं आपको एक और क्वेश्चन देता हूं इस पर on inverting operational amplifier, guys. Now everyone try to give me the answer for this question. This RL is given, right? This is the 10 kilo ohm, it is given, 1 kilo ohm, it is given. Here the 1 volt battery is connected, ground, and the value of the RL, it is given as 10 kilo ohm. Find the value of the current I. What is the value of I? Ideal operational amplifier. Ideal operational amplifier. And this is the question. Ideal operational amplifier, find I. That is the question. Very, very simple. Okay. So what is the answer? Now, if you are going to use the ideal operational amplifier, then what will be the answer? For this question, everyone, I am giving you the 1 minute. Try to solve this question and then I will solve. So, think about it. Your time start now. Okay. So everyone please use your copy, pen and calculator and try to solve this question. Then after that we will solve more question on what differential amplifiers, every type of questions on this topic. And this is the operational amplifier part 1, question practice part 1, then part 2, then part 3. In next part I will discuss what all filters. Then after that I am going to discuss what multi vibrators. Then finally, right, number of topics like what voltage regulator, op-amp with what BJT and so on. So there are 4 lectures, op-amp, question practice 1, then 2, then 3 and then 4. बताओ जरा क्या आएगा आंसर? Yes, please. What is the answer? अरे 2 मिनट हो गए. Please tell me. Okay. Now, time up. Now guys, try to understand. This is a very easy question. In this type of question, remember, first of all, what is the current here? So it is an ideal op amp. So you can apply the virtual short concept. So what is the virtual short concept here? Simply, this will become 0. This is 0. This is called virtual short concept. And what is the current enter into the operational amplifier? 0. Why? Because the input resistance is infinite. So virtual short concept, positive terminal voltage is equal to negative terminal voltage for ideal operational amplifier. Vp is equal to Vn is equal to 0. This is called virtual ground process. It is a special case of virtual short, 0. Then this is the current I. What is the current enter into the op amp? 0. Same current will pass here. Let this is the I1. Same current will pass here because current enter into the operational amplifier is 0. Now here the current is IL. Now first of all you have to find the value of the V0. So value of the V0 you can find by using the nodal or by using what? Non-inverting op amp. So for inverting op amp, what is the gain for the inverting op amp? Minus Rf by R1 into Vin. So this is the minus 10 divided by 1 into Vin is what? 1 volt. So minus 10 volt. Now you have the output minus 10 volt. Right? Now at this point, what is the IL you can say V0 upon RL. V0 minus 0 upon RL, but V0 is negative. Minus 10 divided by 10, that is the minus 1 milliampere. IL is 1 milliampere, means it is moving upward. No problem. Now you can write the KCL at this point. KCL. What is the value of the I1 here? I1 is given by 1 minus 0 by 1. It is a 1 milliampere. So this is the 1 milliampere current. Right now you can write what is the incoming current? I. What is the incoming current? I1. What is the outgoing current? IL. So what is the I is equal to? IL minus I1. What is the value of the IL? Minus 1. What is the value of the I1? 1. So what is the answer? Minus 2. So this is the 1, this is the 1 by 1. So minus 2 milliampere is the current. What is the meaning of the minus 2 milliampere? This current is moving inside the operational amplifier. Inside the operational amplifier. Why Shiva? Why the V0 is 10 by 21? Very simply, if you want to find the V0, write down the KCL at this point. Write down the KCL at this point. If you are going to write the KCL at this point, what is the KCL? 0 minus 1 upon 1. 0 minus 1 upon 1 plus 0 minus V0 upon 10 is equal to 0. You will get the V0 is equal to what? Minus 10. Right? This is the, you can find directly answer. Or otherwise it is an inverting operational amplifier. For inverting operational amplifier, what is the gain? Minus Rf by R1. Minus Rf by R1. It is independent of RL. V0 is independent of RL. Remember. Okay. Now this is the current, guys. This is the current I. So what is the answer for this question? Minus 2 means this current is not moving outside. This current is moving inside the operational amplifier. Inside the operational amplifier. Direction is 2 milliampere. 2 milliampere. Similar question. Now next one. This is RL. Then this is RF 10 kilo ohm, R1 1 kilo ohm. This is ground. Now here 1 volt is connected. One volt is connected. Then tell me what is the value of I. Now again same question, what is the value of I? This time it is a non-inverting operational amplifier. Is it what? A non-inverting operational amplifier. Okay. बताइए जरा क्या होगा आंसर. Please tell me. Tell me guys. Okay then. क्या है आंसर? U naught is 11. Yes. What is the current then? Now, for example, the gain for this is a non-inverting of this is the RL. Value of the RL you can take what? 10 kilo ohm. If the value of RL is 10 kilo ohm, what is the gain? 1 plus RF by R1. 1 plus RF 10 by R1 by 1 into 1. So 11 volt is the output voltage. Very simple. 11 volt is the output voltage. Then what is the current here? Virtual short concept. This is 1 volt. Let this current is I1. What is the current enter into the op amp? 0. This is also I1. So this is I1. This is I1. So what is the I1? 1 minus 0 by 1. So 1 milliampere. 1 minus 0 by 1. 1 milliampere. This is 1 milliampere. Now this is the 11 volt. If this is the 11 volt, what is the current in downward direction? IL. IL is the 11 divided by 10, that is 1.1. 11 divided by 10, that is the 1.1 milliampere. Then finally KCL at this point. What is the incoming current I? What are the outgoing current I1 plus IL? And that is 1 plus 1.1, and it will become what? 2.1 milliampere. 2.1 milliampere is the answer for this question. Yes, Siva. Yes, yeah, you have given the right answer. 2.1 milliampere. So this is the answer. 1 milliampere, this one, this side, because it is a 1 volt, the current in this direction 1. Same current will come from this, because what is the current enter into this terminal? 0. But here there will be the current. So what is the direction of the current outside? 2.1 milliampere, positive answer. In previous question that was the negative answer. Okay. So these are the questions on non-inverting op-amp or inverting op-amp. Now this is the question. In my class I have given the assignments. So what is the answer? A differential amplifier has input 1050 microvolt, V2 950 microvolt, CMRR, that is called common mode rejection ratio. What is the error in the differential output? What is the error? Then if you want to find the error, so first of all, new students get the idea about the differential amplifier. Input is given, V1 is given, V2 is given, CMRR is given. Then you have to find the error. What is the percentage error? Give me the answer. Then for any differential amplifier, remember guys, we are giving the two inputs, V1, V2, and here we are getting the output. Now V0 is equal to AD/VD plus AC/VC. VD is called difference signal, V1 minus V2, and VC is called common mode signal. Common mode signal. This is the wanted term, this is the unwanted term. AD is called difference gain. Difference gain. And AC is called common mode gain. Common mode gain. Right? Now, common mode gain AD and AC. Then this is the unwanted term guys. So CMRR, what is the common mode rejection ratio? Mod of AD by mod of AC. This is called CMRR. So out of these terms, this is the error. So what is the percentage error? Percentage error is given by AC/VC. This is the error upon the wanted term into 100%. That is called percentage error. Now AC should be equal to 0. Ideally AC should be equal to 0. Then CMRR will become infinite. Remember that common mode gain should be equal to 0 and CMRR should be infinite. But it is not infinite. So we are getting the some error. So guys, what is the given in the question? V1 is given as 1 minute. Yes, this is the V1. What is the V1 is given as 1050 microvolt and 950 microvolt. 1050 microvolt and 950 microvolt. You can find and CMRR is also given 1000. It is not infinite, means it is a practical differential amplifier. Practical differential amplifier. And CMRR is called common mode rejection ratio, figure of merit of any differential amplifier. Figure of merit of any differential amplifier. So what is the VC? V1 plus V2 by 2. 1050 plus 950 divided by 2. So you will get the 1000. V1 minus V2, 1050 minus 950, you will get the 100. Now, what is the error? This is the AD by AC is CMRR. So what is the AC by AD? 1 by CMRR. So percentage error is given by 1 by CMRR into VC upon VD into 100%. 1 by 1000 it is given in the question. What is the VC? 1000. What is the VD? 100 into 100%. 1000 cancel, 100 cancel, and you will get the answer 1%. What is the error? 1%. Yes. That is the simple inverting and non-inverting op-amp. That question is based on what? Inverting op-amp. When we are finding the current, na, so current is what? Inverting op-amp, non-inverting op-amp, and that question is based on differential amplifier. That question is based on differential amplifier. Okay. Okay then. Now, so bhai, all the new students, first of all, install our app. That is the Prep Funder. That link is given in description. And second important thing, subscribe our channel. And you can suggest which topic you want. But I am taking the 4 parts of operational amplifier. Question practice 1, then 2, then 3, and then what? 4. And everyone, try to solve question on your copy with a pen and calculator, virtual calculator. Okay. So this is the answer. So what is the answer for this question? 1%. Right. So this is about the CMRR. And always remember, CMRR is given by 20 log. If you want in dB, then 20 log of AD by AC. So if the 1000 CMRR given, so what is in dB? Log of 1000. This is the log base to 10. 10 to the power 3. And that's why it will become 60 dB. 3 multiplied with the 20 and log of 10 is what? 1. Which is a 60 dB. If in this question, if the CMRR is given in dB, then first of all convert it into number. That is the 60 dB. 60 dB. On my post, I am uploading the post. So guys, I am going to daily I am going to upload one post. Did you know? कुछ इंपॉर्टेंट टॉपिक्स वहां पर कवर होंगे जिसके बारे में मैं आपको डिटेल में बताऊंगा. तो आप उसको आंसर कीजिए. पता आप जाकर देखेंगे कि बहुत ही कम लोग राइट आंसर कर रहे हैं. 90% लोग गलत आंसर देते हैं. आई हैव पोस्टेड माई वन पोस्ट फॉर दिस. तो आई एम गेटिंग द रॉन्ग आंसर फॉर दैट. ओके, उसका मैंने डिटेल भी बताया पिछली क्लास में, तो आप वहां देख सकते हैं. देन अब आते हैं जरा नए क्वेश्चन पे और डिफरेंशियल एम्पलीफायर पर. नाउ दिस इज द क्वेश्चन ऑन डिफरेंशियल एम्पलीफायर गाइस. So that is the one question on CMRR, common mode rejection ratio and error. Now another question. For the operational amplifier circuit shown in the figure V0 is there is any differential amplifier is written? No. If nothing is mentioned, AV is not mentioned, RI is not mentioned, R0 is not mentioned, means it is a ideal operational amplifier. Now input is given to both the terminal, inverting as well as non-inverting, means basically it is the differential amplifier. Differential, but both same input is given. 1 volt is given to inverting terminal, 1 volt is given to non-inverting terminal. Same input is given. Then what is the V0? Then guys, first always remember, please students, give me the answer. What is the answer for this question? What is the answer for this question? Yes, 2 minutes. Quickly try to solve. Which question? Differential amplifier. Okay, I will repeat. New student, try to solve this question. Differential amplifier 2 kilo ohm, 1 kilo ohm, 1 kilo ohm, 1 kilo ohm and 1 volt supply is there. Okay, I will explain, don't worry. Time up, time up. What is the answer? Now, this is a differential amplifier. First of all, RF, R1, RP or R3, R2. Always check the ratio. RF by R1, 2 by 1. What is the R3 by R2? 1 by 1. Means RF by R1 is not equal to what? R3 by R2. If RF by R1 is not equal to RP by R2, R3 by R2, R3 by R2, then in one step you can write the answer. So one student have given the answer C. C means what? Point minus 0.5. I will check. Now, if that is the case, guys, there is a one, directly you can write one equation. V naught is equal to gain because of the non-inverting terminal. What is the voltage at the non-inverting terminal? 1 volt. What is the voltage at the inverting terminal? 1 volt. It will become 1 plus RF by R1, the non-inverting terminal gain, into voltage at this point. What is the voltage at this point? R3 upon R2 plus R3 into non-inverting terminal voltage minus RF by R1 into what? Inverting terminal voltage. This is the V2. This is the V1. So 1 plus RF by R1 into voltage at this point. Voltage at this point is given by R3 upon R2 plus R3 into V1, and then minus RF by R1 into what? V2. This is called general formula. In my class already I have derived. Then V naught is given by 1 plus, what is the RF2 divided by 1. What is the R3? 1. 1 plus 1 minus RF2 1. What is the input? 1. Input 1. V1 is 1, V2 is also 1. Then it will become 3 by 2. 3 by 2 minus 2. This is nothing but 1.5 minus 2. That is the answer is what? Minus 0.5. Answer is minus 0.5. So in a differential amplifier, we are giving the same input. Again we are getting the output. Again we are getting the output. Means it is not an ideal differential amplifier. अगर ये ideal होता ना, तो अगर आप same input दोगे, तो आपको output क्या आना चाहिए था? 0. But we are getting the different outputs. मतलब non-zero output means there is a gain because of common mode signal. So then there will be one question on this diagram. Answer is correct, minus 0.5. Answer is correct, minus 0.5. C is the correct answer. Siva, you have given the right answer. All other students, try to solve these questions, guys. Everyone, nice try. Yes. Yes, Bitan Mati, you can join, you can upload our app to where you will get the idea about that. Now, this is the case for the operational amplifier. Now, we are giving the same input, again we are getting the output. It is not a proper differential amplifier, means AC is not 0. And CMRR is not infinity. Then there will be maybe MSQ. Find the CMRR, find the AD, find the AC, what is the output, and so on. So we are going to solve one more question on this diagram. This is the C. And previously I have discussed what? Error. Previously I have discussed the error. What is the percentage error? So remember, a differential amplifier, if the input is given, CMRR is given. So CMRR is given by 20 log of AD by AC. So 20 log of 1000, that is the 60 dB. Second, if you want to find the error, V0 is AD VD plus AC VC. This is error. So you can write the error upon actual value into what? 100%. So this is called percentage error. This is the percentage error, where VC is the common mode signal, V1 plus V2 by 2, and VD is what? V1 minus V2. What is the V1 minus V2? 100 microvolt. What is the VC? Average value 1000 microvolt. And what is the AC by AD? CMRR. Put the value and you can find the error. That is what? 1% error. This was the question from differential amplifier. Okay. This is the very basic question. Error. 1% error we are getting. Negligible error. Then CMRR, again we can find one question on differential amplifier. For example, this is the question. Same question, but you can convert it into what? MSQ. MSQ, multiple select question. First question is what? For the operational amplifier shown in the figure, V0 is minus 0.5 volt if the V1 and V2 is 1 volt. Already we have solved this question. Yes, we have solved. 2 kilo ohm, 1 kilo ohm, 1 kilo ohm, 1 kilo ohm. What was the output? Minus 0.5. Minus 0.5. Second question, what is the value of the CMRR? Differential gain, common mode gain of this diagram. So we will find all these things, CMRR and so on. No. If this question is given MSQ, if for example MSQ it is given, it is of 2 marks question, right, on differential amplifier, then first find the output. This is the formula. RF by R1, R3 by R2, and that is called what? Output. Non-inverting terminal gain, potential at this point, and then what? Inverting gain minus RF by R1, and that is the output is what? Minus 0.5. Means what about the first answer? Correct. First answer is correct. Then CMRR, AD or AC, how we can find CMRR, AD and AC? So watch this one. This term is what? Called A1, and this is called what? A2. A1 and what? A2. तो लास्ट ईयर इन 2024 एग्जाम से 5 दिन पहले मैंने ये क्वेश्चन करवाया था, और यही क्वेश्चन आपका एग्जाम में आया था इलेक्ट्रिकल ब्रांच में, फाइंड द CMRR. तो थोड़ा ध्यान दीजिएगा, इंपॉर्टेंट है. सेम फॉर्मूला हियर, दिस इज कॉल्ड A1 V1, दिस इज द A1 V1 प्लस व्हाट? दिस इज द A2 V2. तो दिस टर्म इज A1 and this term is what? A2. So you can write what is the value of the 1 plus RF by R1. RF, 2/1 into R3 1/1 plus 1 into what V1 minus RF/R1 2/1 into V2. Then V0 is equal to 3/2 minus 2 V2. Now you can find the A1 and A2. What is the value of the A1? 3/2. What is the value of the A2? 2 minus 2. A1 is 3/2 and A2 is what? Minus 2. Now we have the two values, numerical values of A1 and A2. Then according to derivation, what is the AD? Once you have the A1 and A2, you can find the AD. AD is given by A1 minus A2/2 and AC is given by A1 plus A2. This is the general formula. So what is the AD? A1 minus A2, 3/2 minus of minus 2 upon 2. So it will become, this is the 3/2 or this is what, plus 2, 7/2 upon 2. Right? So what is the value of the AD? 7/4. And what is the AC then? A1 plus A2. A1 plus A2, 3/2 minus 2. And that it will become minus 0.5. Or this is the 7/4. What is the 7/4? 1.75. Right? So what is the CMRR? AD by AC. Then it will become 1.75 upon 0.5. So this is what? 3.5. 3.5 is the CMRR. So CMRR you can find. So which answer is correct? CMRR is 3.5. Differential gain AD is 3.5. Wrong. It is half of this. 7/4. 7/4 is 1.75. Then the common mode gain is what? Mod is 1. No, it is 0.5. So we are getting the same ratio. 1.75 divided by 0.5. We are getting the 3.5, but that is not the correct answer. So which answer is correct? A and B. A and what? B. So this type of MSQ on what? Differential amplifier. This is a very, very important question. Last year, please watch everyone. Previous year question on CMRR in electrical branch. In electrical branch on operational amplifier, 2-mark question. Same type of question. So what is the general answer for this? This is a very, very important formula. In my class already I have derived this. This is called A1, that is called A2. Find the A1 and A2, then you can find the AD and AC. AD and what? AC. This is the A1, A2. From this you can find the AD and AC. This is the formula for AD and this is the formula for AC. Then this is the formula for CMRR. Okay. Next one. So new students, please revise it. Make your own notes, short notes, formula notes. But at the end you have to solve the question. पूरा solve कीजिए. आप रटोगे, आपको कोई जादू दिखा देगा, मेरे वीडियोस देखते रहो, आपका सिलेक्शन हो जाएगा, ऐसा कुछ नहीं होने वाला है. जब तक आप प्रैक्टिस नहीं करोगे आप सेलेक्ट नहीं होंगे. कोई भी बोले कि भाई एक चमत्कार हो जाएगा, मेरी क्लास बस दिन और रात अटेंड करते रहोगे तो हो जाएगा, नो। अभी मैं बहुत ही डिटेल में कोर्स ले रहा हूँ जिस पर मतलब नेटवर्क हो गया, एनालॉग हो गया, डिजिटल है, कंट्रोल है, राइट, ईडीसी हो गया, इलेक्ट्रॉनिक डिवाइसेस एंड सर्किट। अरे भाई एक एक चीज को समझाने में टाइम लगता है, बहुत आराम से डिटेल में एक एक चीज को मैं समझा रहा हूँ, तब जाके चीजें समझ में आ रही है। ओके, तो ये है आपका टॉपिक, इसको ध्यान से दीजिएगा। तो ये आएगा CMRR 3.5 एंड सो ऑन, वेरी लो CMRR। नाउ फिर नेक्स्ट क्वेश्चन ऑन डिफरेंशियल एम्पलीफायर इज ऑन व्हाट? इंस्ट्रूमेंटेशन एम्पलीफायर। इंस्ट्रूमेंटेशन एम्पलीफायर, right, this is the instrumentation amplifier. If the RF by R1 is equal to R3 by R2, if the RF by R1 is equal to R3 by R2, for example in this question, yes Shiva, your question is here, RF by R1 is equal to R3 by R2, then if this condition is satisfied, then directly you can say AD is equal to RF by R1, AC is equal to 0, CMRR is become infinite. This is called ideal condition, ideal differential amplifier. So always check the condition. If RF by R1 is equal to R3 by R2, then this is the formula AD, and output will become AD/VD only, because this term is what? 0. This term is 0. And what is the AD? RF by R1. And what is the VD? Non-inverting terminal minus inverting terminal voltage. Non-inverting minus inverting terminal voltage. So this is the V1, this is the V2. Both are 1, 1. So both are 1, 1 means what? RF by R1, this is the, let any value. 1 minus 1, that will become what? 0. Answer will be 0 volt. Answer will be 0 volt. What will be the CMRR? Infinite. What is the AC? 0. And what is the AD? RF by R1. That will be the answer. Is it clear, Siva? Okay. If the condition satisfied, RF by R1 is equal to R3 by R2. So always check this condition, everyone. Okay then. Next question. This is the question. What is the output voltage V0 of the circuit? It is a nothing is given. Again, देखो, name is not mentioned. Name not mentioned, and then normally in GATE exam, they are not going to provide you the name of the circuit. So it is a instrumentation amplifier. Instrumentation amplifier. There are 3 operational amplifier, 1, 2 and 3, right? And this one belongs to a differential amplifier. This is the non-inverting op-amp because input is given to non-inverting terminal, input is given to non-inverting terminal. Here the input is given to both inverting as well as non-inverting terminal. Okay, this is the plus, this is the minus. Inverting and non-inverting terminal, input is given. Then we have to find the V0. This is called instrumentation amplifier. Now guys, solve this question within 2 minutes. You can solve this. So I am going to start timer, then I will solve. Very simple. If you have the idea, then you can quickly solve this. Yes, please. Okay, time over. No. Okay. Now watch this question. Very easy one. Always remember, this is a differential amplifier. Right, because input is given to both the terminal. This is the let the input is what? V01, V02, and this is the V01. This is the output of the first operational amplifier, this is the output of the second operational amplifier, and that is the third one. This is the non-inverting op-amp because input is given to non-inverting terminal, input is given to non-inverting terminal. And how we can solve this? First, always check the ratio. This is the RF, this is the R1, this is the R3, this is the R2. Watch this ratio, it is satisfied. RF by R1 is equal to R3 by R2. All are 4.7. RF by R1 is equal to R3 by R2. This condition satisfied. If this condition satisfied, this is a differential amplifier. So already I have given what is the output, AD/VD. And what is the AD? RF by R1. RF by R1 means 4.7 upon 4.7 into VD. What is the VD? Non-inverting terminal voltage minus inverting terminal voltage. So now we have the value of RF by R1. We have to find the V01 minus V02. So V01 minus V02, very logical. It is an ideal op-amp. Right, ideal op-amp, there is a negative feedback, virtual short concept is valid. This is the 2 volt, so what is the voltage here? 2 volt. And what is the current enter into the operational amplifier? 0. Because the input resistance is infinite. What is the voltage at this point? 2 volt. Now this is the 1 volt, Vp is equal to V and 1 volt. So this is also 1 volt. Can you find the value of I? Yes, we can find the value of I. 2 minus 1 divided by 2. Now this I, if suppose in a particular question the value of I is asked, then this is the I. This I is given by 2 minus 1 from higher potential to lower potential upon 2. 1 by 2 milliampere. 1 by 2 milliampere because it is in kilo ohm. Now watch this. What is the current here? 0. What is the current here? 0. So this I will come from this point. Same I, and this is the I. From this point to this point, I. So guys, what is the voltage at this point? V02. What is the voltage at this point? V01. So you can find the difference of V02 and V01. V02 minus V01. V02 minus V01 is given by I into what is the resistor? 10 plus 2, same current is flowing, plus 10. So V02 minus V01 will become I. What is the I? 1 by 2. And this is resistor is what? 10 plus 10 plus 2, 22. 11 milliampere, 11 volt. 11 volt is the value of V02 minus V01. But what is the output? V01 minus V02. So what is the V01 minus V02? Minus 11. And what is the RF by R1? 4.7 upon 4.71. So 4.7 upon 4.7 into what? Minus 11, and answer is minus 11 volt. Because it is the V01 minus V02. This is the standard formula. You have given the 11 volt, but it is actually minus 11 volt. It is a minus 11 volt. Non-inverting, this in this formula, non-inverting minus inverting. So when I am going to move from this point to this point, you will get the negative value. From this point to this point, it is a positive value. Okay. So minus 11 volt. And what is the value of the I from this to this? Positive. 1 divided by 2, 0.5. From this point to this point, 0.5. But in a formula, actually V01 minus V02. And that's why we are getting negative answer. Yes, minus 11 is given. So Kamini, please check your calculation. Check your calculation. You are getting what? Minus 6 volt. Okay. Please check. This is clear. Important question. This is the instrumentation amplifier. So sometimes they will ask, under ideal condition, what is the resistance seen by this? To infinite. Because what is the current given by this battery? Infinite. What is the resistance seen by this battery? Infinite. Why? Because it is the ideal operational amplifier, and what is the current given? 0. That's why input resistance seen by this battery is 0, infinite, this battery is infinite. That is called what? Ideal condition. The input resistance seen by the battery should be infinite. Right? So that is the case. So already in my class I have explained this. Okay, now next question. One minute. Yes, this is a good question, guys. This is a good question on differential amplifier, or in this way we will almost all type of questions we are going to discuss on what? Symmetry trigger. Right? Symmetry trigger circuit. Okay. Sorry, symmetry. I am talking about the differential amplifier, not symmetry trigger. Now, watch this. Calculation. Try to avoid the calculation mistake, everyone. Now, what was the question? It is MSQ, guys. I will arrange one complete session on what? MSQ. Multiple select question. From analog, from digital, from control, network, EDC. Okay. So, but here mixed question. MCQ, MSQ, NAT, numerical answer type question. So, this is the MSQ. A differential amplifier is constructed using an ideal op-amp as shown in the adjoining figure. Right? The values of R1 and R2 are 47 and 470. Are 47 and 470 kilo ohm respectively. R1 and R2 is given. Right? The MSQ, the first answer what is given here? The input impedance seen looking into the terminal V1 is 47 kilo ohm. The input impedance seen looking into the terminal V2 is 517 kilo ohm. CMRR is infinite. And the last statement is very important one. V1 and V2 are connected to voltage sources. V1 and V2 are connected to voltage sources having an open circuit output of plus 1 volt each, and internal resistance of 13 kilo ohm and 3 kilo ohm. The source resistance are different. Then what will happen? 13 kilo ohm and 3 kilo ohm. Then the output voltage V0 is 0 volt. Right? So there are 1, 2, 3. All are logical answers. Logical answer, very important question on differential amplifier. You can assume this type of questions in differential amplifier. So now, if you want to try, then I will give you the 2 minutes. Otherwise, I am going to solve. Yes or no? How many students want to try this question? Yes or no? कुछ तो लिखिए comments box में. All other students. How many students are watching this session? So, if you want to try, just within 2 minutes. Read this question, you can solve within 2 minutes. Otherwise, I am going to solve this question now. But at least read the question carefully so that I will give you the solution. क्या होता है ना, पढ़ोगे तो आपको ना एक बार समझ में आएगा कि पूछा क्या है क्वेश्चन में. थोड़ा कोशिश करो क्वेश्चन को समझने की कि क्या पूछ रहे हैं. ये भी इंपॉर्टेंट है, कई लोगों को क्वेश्चन ही समझ नहीं आता है क्योंकि बहुत हड़बड़ी करते हैं क्वेश्चन को समझने में और दे आर डूइंग द सिली मिस्टेक. एमएसक्यू मीन्स मल्टीपल सेलेक्ट क्वेश्चन. पहला तो ये ध्यान रखिए, बहुत एक से ज्यादा आंसर सही हो सकते हैं. डिफरेंशियल एम्पलीफायर लिखा हुआ है कंस्ट्रक्टेड यूजिंग एन आइडियल ऑप एम्प. द वैल्यूज ऑफ R1 एंड R2 आर 47 किलो ओम एंड 470. तो दिस इज द 470 47 470 47. तो रेशियो इज सेटिस्फाइड, मींस इट इज आइडियल डिफरेंशियल एम्पलीफायर. What is the input resistance seen by the terminal V1? What is the input resistance seen by the terminal V2? CMRR, and then this is the condition. Read question carefully. Okay then. Now, time up. Any answer? Answer. Now, first, it is an ideal differential amplifier because ratio satisfied. RF by R1 is equal to R3 by R2. So, what is the CMRR of this? Infinite. This ratio is satisfied. 470 upon 4710, 470 upon 4710. What is the AC? 0. And what is the AD? RF by R1? 10. This is the 10 is the AD, CMRR is infinite, AC is 0. First question. But only the CMRR is asked. This is the right answer. Now, second thing, what about the input resistance looking into the terminal V1 and what is the resistance V2? Then, if you want to find the input resistance, remember, the input resistance seen by the V2 means this is what is the current given by the V2. This current will pass through this. And the V2 divided by the current is given as what called input resistance seen by that. V2 upon I2. So what is the I2? V2 upon R1 plus R2. I2 is nothing but V2 upon R1 plus R2. Right, same current will, what is the current enter into the operational amplifier? 0. And that's why when we are keeping this value, you will get R1 plus R2. What is the R1? 47 plus 470. You will get 517 kilo ohm. 517 kilo ohm. What is the answer for V2? 517 kilo ohm input resistance. This is correct. Now, what is the input resistance seen by the V1? If you want the input resistance seen by the V1, then remember, first of all, input resistance seen by the V1. So, my dear friend, this is what you can keep this, what this voltage may be 0, so this is the 0. This voltage is 0. What is the voltage at this point? 0. Why? Because there is no current. This is 0, so what is the voltage at this point? 0. According to virtual short concept, Vp is equal to Vn is equal to what? 0, VGP. Virtual ground process. First make the V2 0, this is 0, this is 0. Now, when that is 0, then what is the current given? I1. What is the I1? V1 minus 0 by R1. And what is the input resistance seen by the V1? R in is equal to V1 upon I1. And what is the I1? V1 minus 0 by R1. V1 by R1. Put here, you will get the answer R1. And what is the R1? 47 kilo ohm. What is the R1? 47 kilo ohm. So answer for this question is 47 kilo ohm. So this is also correct. The input impedance seen looking into the terminal V1 is 47 kilo ohm. Now third is very important one. Watch this. V1 and V2 are connected to a voltage sources having an open circuit voltage of 1 volt each, an internal resistance of 13 and 3 kilo ohm. When we are talking about the internal resistance, so this is the diagram. This is the ideal differential amplifier. (470, 47, R1, R2, 47, 470 it is given. (470 by 47, 470 by 47) that condition satisfied means ideal differential amplifier. कौन यूज करेगा? लेकिन इसको आप यूज करोगे कि यूजर यूज करेगा? राइट अभी देखो, बम फटाके जो है ना, फटाके फोड़ रहे हो दीपावली में, फटाके फोड़ रहे हो दीपावली में, और बनाया कौन है? शिवा काशी में बनाया है फटाका। अब वो तो बना रहा है, वो तो पूरा प्रिकॉशन रख रहा है, बारूद का काम है, लेकिन यूजर है, यूजर महान है, कौन यूज करेगा? पता चला छोटे छोटे बच्चे यूज कर रहे हैं, राइट कोई भी फोड़ रहा है उसको, तो भैया कोई दुर्घटना नहीं होनी चाहिए ना, ऐसा बम मत बना दो कि कुछ भी फूट जाए, तो आपको उसका ध्यान रखना पड़ेगा यूजर का। फिर भी जलते हैं, आग लगती, लेकिन एकदम खतरनाक ना हो जाए। वैसे ही आप इसको यूज नहीं करोगे, यूजर यूज करेगा। अब ये रेशियो को सेट किए हैं ताकि एडी क्या है? 0, एडी आए RF by R1, एसी क्या है? 0, CMRR क्या है? इनफाइनाइट। ये है आइडियल डिफरेंशियल एम्पलीफायर। लेकिन जब यूजर को बोले भाई V1 यहां लगा, V2 यहां, तो उसने लगा दिया एक V1 जिसकी वैल्यू है 1 वोल्ट। इट इज गिवन इन द क्वेश्चन एंड इंटरनल रेजिस्टेंस है 13 किलो ओम। ये देखिए, V1 and V2 are connected to voltage sources having an open circuit voltage of 1 volt, and what is the internal resistance? 13 and 3 kilo ohm. So this is the 13 kilo ohm, and here it is connected 3 kilo ohm 1 volt. My dear friend, if it is an ideal differential amplifier, if you are going to connect the 1 volt battery here, 1 volt battery here, then what will be the output? 0. Why? Because RF by R1 into V2 minus V1. And general answer is what? RF by R1 into non-inverting terminal. Always remember, non-inverting terminal voltage minus inverting terminal voltage. That's why it will become V2 minus V1. Non-inverting minus inverting. Both are equal, so it will become 0. But in this case, what will happen, because of this source resistance of this battery, that ratio changed. 13 plus 47, what is the value here? 60 kilo ohm. And what is the value here? 50 kilo ohm. Now what about the ratio? 470 upon 60. Not equal to what? 470 upon 50. Finished. Ratio disturb हो गया. Once the ratio disturb means it is not an ideal differential amplifier. Or if it is not an ideal differential amplifier means it has AD as well as AC. And we are getting some output, right, for same input. आपने सेम इनपुट दिया है, उसके बावजूद भी आपको आउटपुट मिलेगा. जीरो मिलता अगर ये आइडियल होता तो, लेकिन वहां पर इसका इंटरनल रेजिस्टेंस आ गया. तो व्हाट इज द आंसर गिवन हियर? नो नीड टू फाइंड द आउटपुट. V1 and V2 are connected to the voltage sources having an open circuit voltage of 1 volt, but internal resistance 13 kilo ohm, 3 kilo ohm, then the output voltage is 0. No, non-zero value. And that's why answer for this question is ABC. ABC. And already I have given you the formula how to find the output of this diagram. If you want to find the output for this diagram, because that ratio is not satisfied, then guys, already I have given the formula. V0 is equal to 1 plus RF by R1. RF is what? 470. R1 will become the 60 total resistance, 60 into R3 by R2. R3 by R2 plus R3. What is the R2? 50 total plus this 470 into non-inverting terminal voltage. What is the non-inverting terminal voltage? 1 minus RF by R1. This is the R1 upon 60 into again 1. Now this will give you the exact output, non-zero value. Non-zero value. Right? No, ideal, when we are connecting the any battery or voltage source, that is not an ideal one. What is the internal resistance? 13 kilo ohm and 3 kilo ohm. It should be as low as possible. It should be as low as possible. For example, try to understand. I want to give one example. I am using one mic here. Guys, I am a source V1. In this room, there are two faculty members. दो faculty member है. They are using the mic. अब एक की वायर जो है, this is the wire, wired mic, not a wireless. तो for wired we have the resistance. अब ध्यान देना, मैं यूज कर रहा हूं 10 meters की वायर, and other faculty is using the 5 meters wire. So what about the resistance of the wire? Length increases, resistance increases. Length increases, then resistance increases. So for example, for one source, value of the battery is same 1 volt. But what is the length of the wire? 10 meter. 1 volt, what is the length of the wire? 5 meter. My dear friend, definitely what is the resistance? Rho L by A. Material same, area same, but length increases. Length increases means resistance increases. So for this resistance is 13 kilo ohm. For this the resistance is 1 kilo ohm. So when we are connecting this source to the differential amplifier, we are getting the output without any input. We are getting the output without any input or same input. For similar input again we are getting the output. For similar input, if the inputs are same, what should be the output? 0. But we are getting the output. Okay, so that is the problem with what? Differential amplifier. When we are connecting the source 1 volt and 13 kilo ohm, then this is the problem. Okay, so new students, so what is the solution? So already I have given the solution for this question. Which diagram? 1 minute. This one. What is the solution here? This one. Now watch this diagram. If here the user is connecting 1 volt battery with 13 kilo ohm, user is connecting 1 volt with what? 3 kilo ohm. Doesn't matter. Why? Whether it is a 13 kilo ohm, current will remain 0. Current will remain 0. So what is the voltage at this point? 1 volt. What is the voltage at this point? 1 volt. So 13 kilo ohm and 1 kilo or 3 kilo ohm doesn't matter. So that is the solution. Differential amplifier with what? This is called instrumentation amplifier. It doesn't matter what is the value of the RS, source resistance of the battery. If both are equal, then again you will get the 0 answer. For example, this is 1, this is 1, 1, 1, 1, 1. What is the current? 0. If the current is 0, what is the potential difference? 0. If the potential difference is 0, this is the ideal differential amplifier, and therefore you will get the output what? 0. And that is the solution for this. Solution for the previous problem, instrumentation amplifier. तो जो इतना डिटेल में अगर चीजों को समझना चाहता है, क्योंकि इन इंटरव्यू दे विल आस्क दिस टाइप ऑफ क्वेश्चंस. अगर ये यार प्रॉब्लम है वहां पर, तो व्हाट इज द सॉल्यूशन? इफ यू हैव द प्रॉब्लम, देन व्हाट इज द सॉल्यूशन? तो क्विकली ट्राई टू रिकॉल. Differential amplifier, there is a problem. What is the solution? Instrumentation amplifier. Instrumentation amplifier. Because of that 13 kilo ohm, 3 kilo ohm, this circuit will not work. This circuit, right? This circuit will not work. There is a problem, right? But in instrumentation amplifier, no problem. Okay then. So in my class, I am taking all the care. I am taking care of all the points, all the theory, numericals, and so on. Now, next question on what? Voltage follower, guys. Next question on voltage follower. Voltage follower is a non-inverting operational amplifier because we are giving input to the non-inverting terminal. The given circuit has a unity gain bandwidth product. This is called unity gain bandwidth product, means gain bandwidth product. Remember, this is the property, gain bandwidth product. This is called G for gain, or BW for bandwidth, GBW. Gain bandwidth product is given 12 kilohertz. Will be the bandwidth of the circuit. What will be the bandwidth of the circuit, guys? So for gain bandwidth product is what? 12 kilohertz. What is the gain of the voltage follower? What is the gain of the voltage follower? And that will remain constant. Now you have the gain, so you can find the bandwidth. Tell me which answer is correct. Very easy question. One minute only. Try to give me the answer. Yes, I will upload the PDF. Now, time up. Now the gain bandwidth product is given. What is the gain of the voltage follower? 1. If it is Vi, it is Vi, it is Vi, then it is Vi according to virtual short concept. So V0 is exactly equal to input. So what is the closed loop gain? V0 upon Vi, 1. What is the phase shift? 0 degree. 1. And the gain bandwidth product is constant. So what is the bandwidth? Gain bandwidth product upon gain. 12 divided by 1, you will get the answer 12 kilohertz. Because remember, for any amplifier, what is the highest gain? 1. What is the lowest gain? 1. So it has the lowest gain, and that's why the highest bandwidth. This is the highest bandwidth possible for amplifier. Because for any amplifier, what is the minimum gain? 1. Because the gain should be greater than or equal to 1. Otherwise, it is not an amplifier. It will become attenuator. So it is 1. So gain bandwidth, and when the gain is lowest, what about the bandwidth? Highest, because the gain bandwidth product is constant. The highest bandwidth is what? 12 kilohertz. Highest bandwidth is 12 kilohertz. Right? Voltage follower is what? Very, very important diagram. Okay, watch this diagram, voltage follower. Guys, this circuit is very important. This voltage Vp and Vn are equal. Gain bandwidth product is constant, bandwidth is highest, and then it is find its application in what? Designing of Butterworth filter. Butterworth filter. First order Butterworth filters, high pass filter and low pass filter. Low pass filter. Second, it is used as what? Buffer. Impedance matching device. Impedance matching device. Right? It is used in what? Sample and hold circuit. Hold circuit, designing of sample and hold circuit. That is the part of what? Communication. So this is a very, very important diagram, voltage follower, guys. So this type of questions on voltage follower, gain bandwidth product. Then watch this question. Which of the following statements are correct about the voltage follower? Correct. So actually we are assuming ideal operational amplifier. Yes, we are assuming the ideal operational amplifier. What is given here? It is used in designing of sample and hold circuit. Yes, it is used in designing of sample and hold circuit. Feedback factor beta is nearly equal to 1. Correct. Feedback factor. What is the feedback factor? Output is connected to input directly. This is the feedback. So output is also the feedback. So what is the feedback factor? Beta. Vf by V0. That is called 1. Because Vf is equal to V0. This is the feedback. This is the input. Feedback factor beta is what? 100% feedback. Output. This is the one. Feedback mechanism is voltage series feedback. Wrong. Right. Right. Because it is a non-inverting op-amp. Remember, for non-inverting op-amp, the feedback mechanism is voltage series feedback. This is correct one. Voltage series feedback. Now, what is written? Closed loop gain is 1, not exactly equal to 1. This is not exactly equal to 1. So, I am going to explain you what is the gain. Now, for voltage follower, the feedback mechanism is voltage series feedback, and the gain is given by after feedback or closed loop gain is given by open loop gain upon 1 plus beta AV. Actually, this is the gain. AV upon 1 plus beta AV, and beta is equal to 1. If the beta is 1, then this will become AV upon 1 plus AV. Or AV is very, very high. For example, 10 to the power 6. Open loop gain for op amp is 10 to the power 6. So what is this? But it is 10 to the power 6 upon 1 plus 10 to the power 6. Nearly equal to 1, but not exactly 1. It is nearly equal to 1, but it is slightly less than 1. That's why that answer is wrong. ABC. MSQ. No doubt in every question they will mention what is this MSQ or numerical answer type question or what MCQ. So don't worry about that. In MSQ there is no negative marking. Try to attempt all the question. Numerical answer type question, no negative marking. Try to attend all the questions. Yes, though opposite na, gain decreases, then bandwidth what? Increases. Same thing, gain bandwidth product will remain constant. This is the logic. What is the doubt here? Gain bandwidth product is a constant. So what is the gain 1? So what is the bandwidth 12 kilohertz? Finished. So gain reduce up to what 1? So bandwidth increase up to what maximum? 12 kilohertz. Okay. तो ऑल न्यू स्टूडेंट्स हैप्पी दिवाली। कैसी चल रही है आप लोगों की दीपावली की प्रिपरेशन? दीपावली की प्रिपरेशन क्या है? अभी दीपावली आएगी, फिर थोड़े समय बाद न्यू ईयर आएगा, और देन से भाई आप आपका न्यू ईयर और दीपावली या जो भी है आप लोगों की प्रिपरेशन है, याद रखिएगा। आप जाइए 2 से 3 घंटे दीजिए, लेकिन अपनी तैयारी करते रहो, आप पढ़ते रहिएगा, क्योंकि जो ये अपॉर्चुनिटी है ना ये बार बार नहीं आती। इंजीनियरिंग सर्विसेज एग्जाम के थ्रू IRMS हो रहा है, इसी साल आप क्लियर कर लेंगे। टेक इट सिंसियरली। और एक एज ए इंजीनियर अगर 6 से 8 महीने देते हो आप इन प्रॉपर गाइडेंस, देन यू कैन क्लियर ऑल द कॉम्पिटिटिव एग्जाम्स। ये बहुत ज्यादा इंपॉर्टेंट है। और गुरु ना जो हम लोग हैं, टीचर मेंटर, वो चापलूस नहीं होने चाहिए। बच्चों की क्या फ्लैटरिंग करना, बच्चों को अच्छे से बात करना। स्टूडेंट जो है वो भी इंजीनियर है, हम भी इंजीनियर हैं, राइट। लेकिन एक गुरु का काम होता है कुम्हार जैसा। कुम्हार जानते हो जो घड़ा बनाता है, तो घड़े में जब बनाते हुए देखना, जो अभी तो दिया बन रहा है ना, दिए बन रहे हैं, घड़े बन रहे हैं, राइट। तो आप देखोगे कुम्हार ना घड़े के अंदर हाथ रखता है और ऊपर से लकड़ी से मारता है। ऐसा क्यों करता है? आप बोलोगे, उसको देख के बोलोगे अरे तो लकड़ी से मार रहा है, लेकिन अंदर से सहारा भी तो दे रहा है। तो वो उसको शेप में लाना चाहता है कि ताकि वो अच्छा घड़ा बने। वैसे ही आप लोगों, आपको कोई आपको बटरिंग कर रहा है, आपको चापलूसी कर रहा है, आपसे बात कर रहा है टीचर, तो आप तो बिल्कुल उसके सर पर आ जाते हो। भैया पढ़ना भी है, रिजल्ट्स तो आप दोगे, और रिजल्ट्स अगर आप देना चाहते हो तो टीचर से थोड़ा सा बात सिस्टमैटिक ढंग से कीजिए। वो जो असाइनमेंट्स दे रहे हैं उनको पूरा कीजिए, क्वेश्चन बनाओ, न्यूमेरिकल बनाओ। अरे भाई आपके दोस्त नहीं हैं, दोस्त तब हैं जब आपको डाउट पूछना है। आप कुछ भी डाउट पूछिए ना, मुझसे कुछ भी डाउट पूछिए, रिलेटेड होना चाहिए, इधर उधर की बातें मत करो। आप इधर क्लास 1 ऑफिसर बनना चाहते हो, आप पढ़ना चाहते हो, गेट एग्जाम निकालना चाहते हो, तो सिंसियरिटी दिखाओ ना। मौज मस्ती से तो आपका एग्जाम नहीं निकलेगा। सीरियस मत होइए, सीरियस लोग हॉस्पिटल में पाए जाते हैं। सिंसियर, आई एम टॉकिंग अबाउट द सिंसियरिटी। और जब आप ऑफिसर बन जाओगे तो और ज्यादा आप लोगों के लिए रिस्पॉन्सिबिलिटी आएगी, और ज्यादा वर्किंग होगी आप लोगों के लिए। तो गाइज एकदम स्ट्रिक्टली आप पढ़िए, स्ट्रिक्टली। थोड़ा सा 4 महीने 5 महीने अपनी पूरी पूरी एनर्जी लगा दो, और आप देखिएगा आप ये एग्जाम निकाल लोगे। ओके, बहुत इजी है, आप बस सिस्टमैटिक ढंग से पढ़ते जाओ। कट ऑफ बहुत कम गया है अभी इंजीनियरिंग सर्विसेज का। गेट में भी अभी 3 महीने अच्छे से पढ़ लीजिए, 3 महीने में आप पूरा निकाल लोगे। एक एक चीज को मैं अपनी क्लास में इसलिए डिटेल में बताता हूँ। वी आर डीलिंग विद ऑल द टॉपिक्स इन वेरी डिटेल, कि ये क्यों हो रहा है, कैसे हो रहा है, कहां से आया, क्वेश्चंस बनाओ। फिर क्वेश्चन प्रैक्टिस है ऑन रेगुलर इंटरवल, तो ये कीजिए, क्वेश्चन प्रैक्टिस कीजिए, राइट, अलग अलग वैरायटी ऑफ क्वेश्चंस बनाइए। नाउ ये क्वेश्चन और दिया था मैंने, बताइए जरा। इन द सर्किट shown below, what is the value of the transfer function I naught upon II? बहुत सारे ऐसे क्वेश्चंस आएंगे दोस्तों, आई नॉट अपॉन आई आई, आपको रेशियो निकालना है आई नॉट अपॉन आई आई का। देन क्या होगा रेशियो? अ बटरवर्थ वाली स्लाइड, दैट इज द एप्लीकेशन। ओके, तो न्यू स्टूडेंट प्लीज ट्राई टू सॉल्व दिस क्वेश्चन। Applications of that we will discuss all the application. What are the applications of the voltage follower, Butterworth filter, high pass filter and low pass filter? In next class we will discuss impedance matching device in paid classes. In next I am going to start with what, linear wave shaping circuit, where we will discuss high pass filter, low pass filter, then we will design with the op amp, that is called Butterworth first order filter. Then it is used for what, impedance matching device. So again you will get the idea what is the impedance matching device, and then what is the sample and hold circuit. Sample and hold circuit. Now in the circuit shown below, what is the value of the transfer function I naught upon II? देखो, this time the current ratio is asked, I naught upon II. At this point, what is the current enter into the operational amplifier? 0. At this point, what is the current enter? 0. This point is connected to ground, but there is the current. Already we have solved one question, find the current I here. So there is a current enter or leaving this terminal. So there is the current. Now we have to find I naught upon II, not the I. But remember there is a current. So what is the II? II will not enter here. This is the II. Then this is the I naught. So how we can find the ratio between I naught and II? Okay. Easy question. One minute. One minute. What is the problem here? Very, very easy one. Remember, this current enter into the operational amplifier is 0. This is the ground. This is the voltage. This is also a virtual ground. Then it will become easy for you. Okay. Now, time up. Easy question. What is the answer? Then already I have given the assignment in my class. When you want I naught upon II, remember guys, this is the Vp, this is the Vn, both the voltage are 0. This voltage is 0, this is 0, this is called virtual ground process. Let at this point voltage is V out because it is the output terminal. So what is the current enter into the op-amp? 0, this is the II. And what is the current here? I naught, this voltage is 0. So you can write the II is equal to 0 minus V naught upon Z2 minus V naught upon Z2. What is the I2 is equal to? What is the I2? I2 I naught. This is the I naught. V naught minus 0 upon Z1. So don't make it complicated. V naught upon Z1. My dear friend, I naught upon II. Take care of the ratio. I naught upon II. V naught upon Z1. V naught upon Z1 minus V naught upon Z2. So V naught cancel, minus Z2 by Z1. Very simple. Minus Z2 by Z1. So answer for this question is minus Z2 by Z1. A. Okay. So in number of questions you have to apply the KCL, nodal equations, right? Incoming current is equal to outgoing current with the property of the op-amp, virtual short concept. What is the current enter into the op-amp? 0. Under with, if nothing is mentioned, ideal operational amplifier. Otherwise they will mention the practical values. Okay. So this is a ideal operational amplifier. And the answer for this question is minus Z2 by Z1. So, right. This time we are getting this type of questions. Then there is another topic guys already I have covered in my class. That is, everyone try to give me the answer for this question. What is the load current IL in the circuit below? This is the assignment, everyone. Please write the answer in comments box. In next class I will discuss. And I am just mentioning the name of this circuit. What is the name of this circuit? Tell me. What is the name of this circuit? What is the load current IL in the circuit given below? So just I am giving you the hint. This is the RF, this is the R1, this is the RP, this is the R2. There is a positive feedback as well as negative feedback. And this is nothing but RL. And you have to find the IL, current through the RL. Right? And what is the name of this circuit and what is the answer for this question? Everyone try to give me the answer in what comments box. Okay, comment box में आप अपना आंसर लिखिएगा कि क्या आंसर आता है. Then अब मैं आपको बता दूं, देखो भाई हमारे इसमें हम लोगों का कोर्स चल रहा है जो अभी स्टूडेंट्स वन स्टूडेंट आस्क मी व्हाट इज द कोर्स हियर. तो वी आर टेकिंग दैट व्हाट सुपर 5. Right, Super 5 means what? Live classes. You can download the app and you will get the detail about that, which 5 subject. These are important for GATE 2025, 2026 and engineering services exam, right, through what? UPSC. And I am taking what? Not like a crash course, put a complete detailed course of the 5. And quickly you can complete. What are the features? Similarly, you have the Super 4. You can go through the app and you will get the idea. ऐप डाउनलोड करो, आपको सब पता चल जाएगा. सभी सब्जेक्ट्स मैं लेने वाला हूं. अगर आपकी फ्रीक्वेंसी मैच होती है, आपको मेरी बात अगर समझ में आती है तो आप ज्वाइन कीजिएगा. अदरवाइज आप पहले लेक्चर कर लीजिए, यही डेमो लेक्चर ये समझ लो एक तरीके से, और आपको मेरी बात अगर समझ आती है पुराने लेक्चर्स और भी देख लीजिए. साथ में आप लाइव सेशन अटेंड करना चाहते हो, रिकॉर्डिंग्स भी देखना है, प्रीवियस ईयर क्वेश्चंस भी बनाना है, क्वेश्चंस फ्रॉम स्टैंडर्ड टेक्स्ट बुक. और सबसे इंपॉर्टेंट है भाई, ड्यूरिंग माय क्लास जो भी अटेंड कर रहा है वो यहाँ पे कमेंट्स लिख सकता है. आपका जो डाउट क्लियरिंग होता है ना, जो ड्यूरिंग क्लास, कि सर ऐसा क्यों आया, वाई, मुझे तो नहीं समझ में आया, एंड सो ऑन। ये सब क्वेश्चंस के जवाब मिल जाते हैं ड्यूरिंग लाइव क्लास। और आप चाहें तो मुझसे और भी क्वेश्चन पूछ सकते हो, लेकिन जब आप क्वेश्चंस बनाओगे तब पता चलेगा, राइट। तो आपको मैं ये बताना चाहता हूं कि कैसे रिकॉर्डिंग होती है, क्या क्या क्लासेस चलती हैं। देखो, आपने करीब करीब 1.5-2 महीना बचा है, नवंबर एंड दिसंबर, और जनवरी में रिवीजन करना है। अगर आपने 5 सब्जेक्ट में भी एक्स्ट्रा ऑर्डिनरी कमांड कर ली ना, तो आप टॉप रैंक अचीव कर सकते हो। तो कैसे पढ़ना है, क्या तैयारी होनी चाहिए, ये सब कुछ। एंड गाइस, ये जस्ट एक, अगर आपको कोई सेपरेट बैच ज्वाइन करनी है तो वो भी है, लेकिन मैं आपको प्रेफर नहीं करता कि आप इंडिविजुअल सब्जेक्ट ज्वाइन कर रहे हो। ओके, आपकी अगर तैयारी पूरी है, एंड इफ यू वांट टू ज्वाइन एनी पर्टिकुलर सब्जेक्ट, फॉर एग्जांपल एनालॉग और कॉम्बिनेशन ऑफ नेटवर्क एंड एनालॉग एंड सो ऑन, यस यू कैन ज्वाइन, बट फॉर मोर डिटेल go through it. Okay, and guys, some in तो ये है आपका, we are using that, you can use this code also, save 40 for 40% डिस्काउंट। ये दिवाली ऑफर है आपके लिए, अभी भी टाइम है, स्टार्ट योर प्रिपरेशन। यू कैन यूज दिस सेव SAVE40 फॉर 40% डिस्काउंट, दैट इज गिवन इन अ डिटेल इन व्हाट आवर ऐप, राइट। तो ये मेरी प्रोफाइल है, आपको पढ़ना है और कॉल कर सकते हो आप। हर स्लाइड में मेरा नंबर लिखा हुआ है, आपने देखा ही होगा। दिस इज माय नंबर, यू कैन मैसेज ऑन दिस नंबर, व्हाट्सएप कीजिए, मैसेज कीजिए, देन आवर टीम विल कॉल यू। ओके, तो इस दिवाली में आप लोग एक कमिटमेंट तो लीजिए कि इस बार वी वांट टू गेट द टॉप रैंक इन दिस एग्जाम। अभी भाई कल गए कोई मुझसे बोल रहा था धनतेरस में आप क्या खरीद रहे हो। यस, ऐसा ही बोला जाता है ना, धनतेरस में कोई बर्तन खरीदता है, कोई क्या करता है सोना खरीदता है, कोई कुछ खरीद रहा है। दीपावली में नॉर्मली हम लोग नए आइटम्स लेते हैं, कोई कपड़े लेगा, वो तो सब अच्छी बात है, फटाके फोड़ोगे। अरे अपने ज्ञान के लिए भी कुछ लो, आप अपना नॉलेज, अपनी स्किल कैसे बढ़ा रहे हो। ओके, अपने स्किल पे थोड़ा टाइम दो, टाइम इन्वेस्ट करो, सबसे इंपॉर्टेंट। और आप जितना आप नॉलेज लोगे अभी, चाहे आप कॉलेज में हो तो क्या, चाहे आप जॉब में हो तो क्या। कई लोग जॉब में है ना, जिनको लगता है जॉब ले लिए तो बस हो गई जिंदगी खत्म, जिंदगी खत्म हो गई, बस बोले वहीं से, मतलब अब तो जॉब लग गई, मस्त चल रही है लाइफ। अरे कुछ नहीं चल रही है। आज चाहे वो गवर्नमेंट जॉब है तो अच्छी बात है, लेकिन आपको काम तो करना पड़ेगा। और अपने आप करियर में ग्रोथ चाहते हो तो आपको रेगुलर पढ़ना पड़ेगा, राइट। तो रेगुलर नॉलेज का ये अच्छा सोर्स है ऑनलाइन क्लासेस। अभी मुझे ऐसा लगता है ऑफलाइन में तो क्या होता है, ऑफलाइन तो और अच्छी बात है, 1-to-1 इंटरेक्शन होता है, बातचीत होती है, डाउट क्लियरिंग सेशंस होते हैं। लेकिन अगर पॉसिबल नहीं है तो उनके लिए जो जॉब में है, जो कॉलेज में है, जो घर पर है, राइट, जिनकी शादी हो गई, वो पढ़ नहीं पा रहे हैं, आ नहीं पा रहे हैं दिल्ली मेट्रो हैदराबाद, तो वो अपने घर पर तैयारी चालू करें। सबको अपनी तैयारी करनी चाहिए। चाहे आपको अगर कोई अपॉर्चुनिटी है एग्जाम देने की तो एग्जाम दीजिए, राइट। अदरवाइज आप नॉलेज लेंगे तो इस नॉलेज के दम पर आने वाली जनरेशन को आप पढ़ा पाएंगे। कोई भी आप काम कर पाएंगे, घर बैठे बैठे फ्रीलांसर का काम आ रहा है वो आप कर पाएंगे। VLSI की डिजाइन बना सकते हो वर्क फ्रॉम होम में। आपको VLSI में आपको डिजाइन ही तो बनाकर देना है। तो अगर आप ये सब चीज सीखते हैं तो अपने नॉलेज पर इन्वेस्टमेंट कीजिए, और ये जो इन्वेस्टमेंट है ना, वो होगा इस दीपावली का गिफ्ट। ये जो आपका ज्ञान है ना, जो नॉलेज है ना, वही आपके लिए सोना है। कितना ही सोना आप कमा लोगे, राइट। तो इसीलिए टाइम का यूज कीजिए। और ये जो कॉम्पिटिटिव एग्जाम्स होते हैं ना, खासकर गेट है, इंजीनियरिंग सर्विसेज, या फिर आप खुद देख लीजिए 12th में अगर आपको कॉम्पिटिटिव एग्जाम्स ना देना पड़े तो इतना फिजिक्स केमिस्ट्री मैथ्स कौन पढ़ेगा बताइए। पढ़ते आप फिजिक्स केमिस्ट्री मैथ इंजीनियर्स, या कोई भी कॉमर्स वाला CA की तैयारी करता है तो इतना डिटेल में पढ़ता है। सिमिलरली आप UPSC की जब आप तैयारी करते हो या फिर गेट एग्जाम की तैयारी करते हो ना, तो सिस्टमैटिक ढंग से पढ़िए, क्योंकि एक बार पढ़ाई छूट गई तो दोबारा नहीं होती। तो आप बाद में क्यों पढ़ोगे भाई, फिर जो आप काम करोगे उसको काम को कीजिए। तो अच्छे प्लेटफॉर्म में पहुंचने के लिए आपको थोड़ा सा एफर्ट लगाना होगा, और उस प्लेटफॉर्म के बाद में आप बहुत तेजी से आगे बढ़ोगे। मैंने आपको कई बार समझाया है, हर जॉब में एक हायरार्की होती है दोस्तों, याद रखो, ये हायरार्की है। ओके, ध्यान दीजिएगा जरा, ये नहीं, यहां से एक लेवल है और ये एक लेवल है। अगर आप तैयारी नहीं करोगे ढंग से तो आप यहां एंटर करोगे जहां पे नीचे लेवल पे होता है जूनियर इंजीनियर वगैरह। इसके भी एग्जाम हो रहे हैं आरआरबी के, कोई बुरी बात नहीं है, आरआरबी का भी एग्जाम आप निकाल सकते हो। लेकिन आरआरबी से अगर आप बोलोगे कि मैं रेलवे बोर्ड का चेयरमैन बन जाऊं तो पॉसिबल ही नहीं है। इतना तो आपका प्रमोशन ही नहीं होगा, राइट, कितना भी आप में नॉलेज क्यों ना हो। ओके, लेकिन अगर आप थोड़ा एफर्ट लगाते हो और आप इंजीनियरिंग सर्विसेज एग्जाम से आईआरएमएस में आ जाते हो, इंडियन रेलवे मैनेजमेंट सर्विस, डायरेक्ट आप बनोगे क्लास 1 ऑफिसर। और फिर मैंने आपको अपना एक लिंक दिया है डिस्क्रिप्शन पे, उस पर जाइए, पूरी सैलरी पैकेजेस वगैरह मैंने बताया है, वहां से आपका कैसे प्रमोशन होगा। और प्रमोशन बहुत फास्ट होगा और आप एक दिन बन जाओगे, पॉसिबिलिटी है कि आप क्या बन जाओ, चेयरमैन। तो देखो, डायरेक्ट रिक्रूटमेंट, डायरेक्ट एग्जाम देते हो इंजीनियरिंग सर्विसेज का या गेट का भी एग्जाम देते हो तो किसी ऑर्गेनाइजेशन के आप इस लेवल पे एंटर करते हो और फिर उसके बाद प्रमोशन होते जाता है। अगर आप इस लेवल पे एंटर करोगे ना तो यहां से यहां पहुंचने में ही 25 साल लग जाएंगे। आप समझ रहे हो? आप यहां से यहां जाने में 25 से 30 साल लग जाते हैं, यहीं तक नहीं पहुंच पाते, यही खत्म आपका पूरा करियर, जॉब खत्म, करियर यहां पे दी एंड होता है, रिटायरमेंट आ जाएगी आपके। और जबकि आप यहां से यहां जाओगे और 25 की एज में एंटर कर रहे हो, 25 और लग गए तो 50 साल में आप उसके चेयरमैन। उसके बाद देखिए, फिर उसके बाद रिटायरमेंट के बाद भी बहुत सारे ऑर्गेनाइजेशन के आप चेयरमैन रहोगे। तो ऐसा है, तो अपनी तैयारी अच्छे से कीजिए। और ये जर्नी यहां से स्टार्ट होती है, ये मैं जानता हूं, मैंने जॉब की है तो मैं बहुत अच्छे से समझता हूं इस बात को। और मैं यहां पर हूं क्योंकि मुझे पढ़ाना पसंद है, मुझे बताना जरूरी है बच्चों को कि आप सही टाइम पे अपना करियर स्टार्ट कीजिए, बेफिजूल में अपना टाइम पास मत कीजिए। जिनको नॉलेज नहीं है ब्लफबाजी में मत पड़िए, बहुत सारे विवाद होते रहते हैं यूट्यूब में, उस पर मत ध्यान दीजिए, ठीक है ना। दीजिए थोड़ा बहुत, 1-2% आपने देख लिया वो कोई दिक्कत नहीं है, लेकिन पूरी तरीके से उसमें डूब गए आप तो फिर दिक्कत है। तो अपनी पढ़ाई पर फोकस करो, इजी है, कोई ऐसा नहीं है कि बहुत टफ एग्जाम है कि आप नहीं निकाल सकते। इसीलिए हम चाहते हैं कि आप अपनी तैयारी स्टार्ट करो इस दीपावली में। ओके, तो अच्छे से कीजिएगा, स्टार्ट योर प्रिपरेशन नाउ गाइज, एंड देन अगेन हैप्पी दिवाली। थोड़ा अपना केयर कीजिएगा, घर वालों का केयर कीजिए और अच्छे से त्योहार मनाइए और एक कमिटमेंट के साथ वापस आ जाइए अपनी तैयारी पर। ओके देन, थैंक यू फॉर अटेंडिंग द सेशन। Everyone, please like the session, share the link of this session and subscribe our channel. Again, happy Diwali.